Actually, you know what? We're going to look at this problem. The second blank one. Because it's got the most going on with it. So we can talk about it. Negative 1/3. I need somebody to do me a favor and tell me what it was. F of x equals what? I'm gonna pick on somebody to be a spokesperson here. What was it?
Negative 1/3
Mm-hmm.
absolute value x plus 1 and then minus 2.
Okay, so knowing what we know from just we're trying to start with the parent function of this. We know that what kind of shape does that blue one make? Is it a straight line? Is it a U?
V.
It's a V. Yeah, it's a V, right? And it opens up. The vertex of this guy, of the original, is at 0, 0, which, I'm just kind of drawing it off to the side there. But so if I know that that's kind of where we're starting, let's talk about what this and this value mean. Because in my table, it asks, am I moving left or right, up or down? Is there a vertical shrink or stretch? So what is a 1? What's that tell me? And I was hoping that what we just did in the Desmos helps you now apply it to this, right? Instead of our what was it, a parangula or whatever? Now we've got an absolute value. So the parangula, the made up thing, it still has the same properties when we transform it.
Move left 1?
Yeah, exactly. Since it's happening inside of our symbols and our grouping symbols there, you have to switch the sign because that what we're applying there actually affects it. So we have to, here we are left 1. Ooh, see, and I've got something set. Oh, I think that's what this guy is. You guys see what I'm pushing up here? See where the little hand symbol is? And then next to that, there's this guy. I think that if you have that set and you're in OneNote and you go to, like, let's say draw something, it automatically makes a little, like, you can undo it and it'll do your exact drawing, but like I made that kind of wonky looking circle and it made a little oval for me. Anyway, okay, that's cool. So it's moving left 1. How about, what does this tell me? Minus 2.
Down 2?
Yeah. So this is going to be down 2. That always tells me up or down, and since that's negative, it's going down. All right, so the big question, what does this tell me? That's my vertical, yeah. Yeah, it's doing something with vertical. Oh, and there's something else that's happening, right? The negative tells me one thing, but the 1/3, that tells me that it's got a vertical, are we shrinking or stretching?
Shrinking.
Yeah, we're shrinking. Thank you guys for piping up. And if you want to, as long as you don't have, like, crying children in the background, you can unmute you guys yourself if you want, and you can, that way it might be easier for us to all join in. But we're shrinking by a factor of 1/3. What's the negative tell me?
Reflecting.
It'll flip.
Yeah, it's reflecting. Good. It's flipping, right? On the x-axis. All right, it doesn't ask you to graph it, but you have to really be able to imagine what this looks like in order to find the domain and range. Like I said before, the domain, and well, let's graph this guy. So if normally it starts looking like that blue V up there. We're taking that left one. I'm referencing the vertex. So left one and then down 2. That's going to be our new vertex. It's reflected across the x-axis. So is it going to be opening up or down?
Down.
Yeah, it's going to be opening down. So instead of this guy, it's going to look like that. And so it really, we can try to make it exact, but I know that since it's a 1/3 as opposed to a number bigger than 1, it's going to be more narrow looking, right? It's going to be like kind of compressed versus flatter. So, or no, I just said that wrong. The opposite of what I just said. So negative 1/3 will look like flatter. So I apologize. So let's see. It would look something like maybe like this. All right. So that being said, now if I am needing to write the domain and range, and all that was asking for was the range, but still, let's just get in the habit of how to write that. Domain and range, this is where it was written like you start from the left to the right for domain, bottom to top for range. And I shouldn't have done the parentheses on both of them yet, but it's either going to be a parenthesis or a bracket. Parenthesis means that that point that you're referencing is included in the graph. Bracket, it's not. So if we're ever talking about infinity, infinity is something that it'll approach, but infinity is not like an actual number, right? Like it's something that it goes to. So that's always, if it's infinity, it's always going to be open. And like I said, for our domain, we're talking left to right. And if I'm looking left to right, we're starting at negative infinity and we're moving to positive infinity. This graph keeps going in both of those directions. So you would write, if I was asking you that, this is how it would be written. For the range then, range is from the bottom to the top, right? So it's from down here, it's coming from where? Is there like a bottom limit? Yes or no? That's all I'm looking for you guys. Is there a bottom number that starts at? What do you guys think? No, it doesn't have a lowest point, right? It starts from negative infinity from down here. And then it does have a high point though. What's the highest point there?
-2.
Yeah, it's right here. And when I'm talking about, the highest value here, I'm looking at the y, and my y is -2. And that's included, so I have a bracket sign. This is actually what you need to be writing in that space. If I'm looking at this, it's got a space for range right below the, come on, dang thing, okay. Right below the function that it gives you. So what did I say? I said negative infinity to -2. Is that right?
Yep.
And you guys are going to notice that the number that, tells us and helps us figure out that range is always that up or down translation from outside the parentheses. So just looking at the one right above it, I don't even, at this point, looking at the one right above it, I'm not 100% sure if that's the highest point or the lowest point quite yet, but is the 5 or the -6 gonna be what defines our domain or our range? I'm sorry. What do you guys think?
-6.
Yeah, the -6 is going to be either the highest or the lowest, and that's really determined on if it opens up or down. This one opened down, so it's got a high point. That one right above it opens up, so it's going to be a low point. So it's not going to be parentheses negative infinity. It's not going to have started from the bottom forever and going up. The other things that you need in this for this first one here, we said it went what? Left. What do we have? Left 1, down 2. So when you go to enter this into Canvas, you'll put a left, let's see, sorry. Left 1, down 2. It had a shrink of 1/3. It reflected across the x-axis, so yes. Everything else you can leave blank. Or you can put a dash or no or whatever, but okay, does that clarify some issues that maybe anybody was having with the homework?
So you said for the up and down, we don't have to put anything for that?
Yeah, we did. We put 2 down.
Oh, no, I mean, right and up, it says you put a dash on it. It shows that you put a dash on it.
Yeah, because it doesn't move. It didn't move that direction, right? It's either going to be one of the two, left or right, or, and then it's going to either be up or down. Or if it didn't translate at all, up or down or left or right, you could have a dash in both of those.
Okay.
Okay, like maybe it didn't move. You know, it's still at the point 0, 0 at the origin there. So let's look down here though. I want to at least do one more. What time is it? 42. Okay. Before I kind of send you off to work independently. Let's look at these linear ones that I've got down here. Actually, hold on just a second. Let me look at something. Okay. Let's look at, I think instead of this one, I'm gonna have us look at this one. So here we're just given that some certain properties on it. Now, I want you to, I mean, you could write this as an absolute value or you could write it linear. So there are like a lot of these, actually almost all of them, those bottom ones where you have to draw and write in the function, almost all of these down here are completely like, there's multiple answers. That's why it was really hard for me to create this in, like I couldn't find it in Big Ideas because Big Ideas is all either like multiple choice or whatever, and it doesn't have something like that. So it wants you to come up with a function that has these things as true. So if I made, let's see. That straight line did not work out real well, did it? Ooh, all right, that's right. Okay. We don't know what f of x is, but we do know that it went, what direction? Somebody read that one to me, the one that first one, well, I think the second to the bottom one. What directions it went?
Left 2, up 5, stretch 4, and then reflect across x-axis.
All right, thank you. All right, so we could do a linear. We could do absolute value. What do you guys want to do? It doesn't really matter in this case. So let's do linear because we haven't really done any linear ones. So if I'm starting with the regular, you know, parent function, f of x equals x, that's just this straight line that goes through the origin, and it goes through points 1, 1, 2, 2, 3, 3, 4, 4, right? So I want to move that line, and I'm going to start with the origin, and that picture that I just drew did not draw my line to the origin, did it? Dang it, and I just erased the whole dang thing. Oh, whoa, hello, okay, there we go. So I want to move this guy up 5 and over 4. We're going to reflect across the x-axis, so like whatever point that origin got moved to, we're going to move it down here. And we're going to stretch it 4. So, all right. Up 5, 1, 2, 3, 4, 5. Left 2. We're reflecting across the x-axis. Well, let's draw kind of a what it looks like first before we reflect. If I'm stretching 4, that means, am I getting steeper or flatter? What do you guys think?
Steeper.
Yeah, it's a bigger slope there ends up giving me a, you know, like a bigger hill that I got to ride my bike on. And actually, you know, the slope is going to be rise over run. You can think of, since this is linear, that means we're going to go up 4, right 1. Ooh, stop with that. I don't like that. Okay. So up 4, right 1 from that point. So our original line is going to look something like that, but I need to reflect that across this axis. So I could do that. Our new line would look something. You don't even need to graph this, but I'm just doing it so we can kind of have an idea when it comes to writing this out. But 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So like any point, and really I just need a couple points that it goes through. So any point that it went through, let's see, 1, 2, 3, 4. So like this point's going to be here. It's going to look something like this. So if I'm asked to write this out as linear instead of f of x equals x, what number should I write first? I got a 2, a 5, a 4. Then I got something that's happening here with the reflection. Anyone want to take a guess of what number I should write first? Out of these up here, what is the reflection across the x-axis going to do to our number?
Negative.
Yeah, it's going to make whatever we write here negative. And so which of these is going to be negative, the 2, the 5, or the 4, based on that reflection?
The 4.
Yeah, and so we're going to start with -4. That's going to be before our grouping symbol. And then since it's linear, I'm not going to put the absolute value. Now, you could have done an absolute value in which you put the absolute value bars right there, and that would have been correct as well. And that range is going to be different than had we did what we're doing right now. And that would have been accepted. Okay, so -4. We have x. We're going left 2. So am I adding or subtracting the 2?
Adding.
Yeah. And then I'm going up 5. So here is what would go in that blank for your f of x. Our range and domain, in this case, any linear, when you were talking about linear functions, they extend, unless you're just talking about a segment part of it, the domain and range are just all real numbers. And to write that like we want to write it, and this is again why I don't use big ideas for this, because they write theirs in a different notation. The higher maths you guys get into, this interval notation is what it's called, is what how you're gonna write domain and range. Okay, so you need to get used to writing it like that. And all the like AP teachers and pre-AP, all of those people, that's how they write it. And that's how they want you to get used to writing it. So those are the two answers for that one. Because that's, so what did I say? -4. Parentheses x plus, was it +2? +5? All right. So we have, what, maybe about 10 minutes. I want to use that as best as I can. Are there questions on this bottom part that I need to go over?
Could you go over the one where it's not even, that second one in the first line?
Sure, yeah. So if I am, and here's another one that you could have a ton of different answers for, right? But for sure, it's saying my y-intercept is 0, -5. Y-axis is this axis, right? So 0, -5, 1, 2, 3, 4, 5. I know that and these are all going to be absolute value. It tells you in the direction. So they're all going to be a V. And it wants it to not be even. Does anybody remember the definition of it not being even? Or I'm sorry, it being like a function being even?
It's symmetric over the y-axis.
Yeah, exactly. It's symmetric across the y-axis, which means that if you took your graph and folded it in half, the graph would line up on itself. I don't want that to happen, okay? So if it's not even, it doesn't, you can't, if I folded it, it would not line up on itself. Okay, so as long as it goes through that point and it's a V, you're good. So, you know, if I choose, let's say I want it to go, let's say I want that to be my vertex, what that new dot I just drew, the new point. If I folded this guy on the y-axis here, would it line up on itself? No. So this would work. Now, how do I write that as a function? Well, let's say I'm not going to stretch it or shrink it at all. You could play around with that and make it do that if you wanted. But for our purposes, you know, I'm taking that original parent function that looks like this, and I moved the vertex down here now. So I went, what? And in my case, I went to the left 2. So that's adding 2 inside the absolute value. And I went down 3, 4, 5, 6, 7. So this was the point, -2, 7, -7. So that would have worked. There's a ton that would have worked. Could it have opened down? Yeah, you totally could have had it open down. I would have had a negative symbol outside the absolute value bars. I had a lot of questions from you and my other classes about this bottom left one. What does it mean if the lowest point is in quadrant 2? Well, first you got to remember what the quadrants mean, like which quadrant is which. And quadrant 1 is this top right quadrant because everything is positive. X and Y's are positive. Then it goes around this way. So it goes, this is quadrant 2, this is quadrant 3, this is quadrant 4. So if the lowest point is in quadrant 2, and I'm talking absolute value here, am I going to have I got a V shape, right? Am I going to have it opening up or down?
Up.
Yeah. And it really does not matter anything else about it. It's just that it's got some low point in that quadrant. And then you just have to go in and you know, put, is it X plus or minus, whatever. Well, in this case, it does have to be, now that I'm writing that, since it has to be in this quadrant, the shift to the, it does have to be have a left shift, right? And it does have to have an up shift. So it's going to have to be, regardless of what number that is, it's going to be a plus. Remember, it's inside that grouping symbol. So the number that you move to the left is in, or is flipped sign wise, and then up however many I got. So plus whatever number I had here. And I'll let you guys, whatever you put in there. Anything else on this? We're running out of time, and I want to make sure that I guarantee if you've got a question, other people probably have questions. Okay, this is what I need from you guys. And if you have a question and I haven't answered it, stick around. It's not like at 3:02 or 3:05 or whatever. I'm like, if there's still questions, I will answer them. But I need you to, for sure, this has to get done. And I might have to adjust due dates and things. Like, don't worry if it says late. If you need me to write a note to your folks or something, if they're freaking out because things are showing up weird, because, and it's not that I know that you hadn't assigned it or I hadn't assigned it. It's just that I hadn't put it in Canvas because I didn't want you guys submitting things in like the way that I didn't want them submitted. Okay, I need something. I need you guys to come back. Can you just wait for a couple minutes? Ask her if she can come in and wait. And then you do have a new lesson and assignment 1.2. It's not as long as this one. And it's just building on this. And I think since you spent a lot of time in this Desmos, actually part of the assignment is actually doing a Desmos thing. All right, and so if you've tuned out, I need you back with me for a second, because if you get into the assignment, I don't know if I can even get into it this way on my app. But for 1.2 assignment, I have uploaded the PDF. Just a couple minutes, please. So you're gonna go in and watch some videos and do some problems. Okay, here's what I don't know how it's gonna work. Part of the assignment is doing this Desmos activity. I think I have embedded it correctly that you can go in, enter this code, you will be automatically put into the class, and I can see that. All right. If not, if it doesn't work that way, the PDF, which is part of your notes for this section, like there's only really like 2 parts to the homework. It's pretty short. Has a recording part on it. Worst case scenario, you just record, oh shoot, and it's sideways. I'll go in and fix that. But you go in and record your answers just in this first box. That's fine. I'm just trying something out to see if you can actually do it Desmos, like embedded in there. But then as soon as I did that, I was reading things people are having issues. So we'll try it. Make sure you're in your like iPad when you're trying it. So hopefully that'll make it work better. Okay, I need a rating on 1 to 5 on how comfortable you are feeling, and at least you know what you're supposed to be doing, and if not, you have a plan of when you're going to contact me. So in the chat, privately message me before you leave. Okay, I'll go back and read those. I might not get back to you right away, but I will. If you need to reach out to me and you haven't heard from me over the weekend, reach out to me. Okay. But if not, you are good to go as soon as you 1 to 5 and have an explanation if it is not a 4 or 5. So bye guys, have a great weekend. Enjoy the good weather. Oops.